The title of this next session is Oracle Cloud Infrastructure Automated and Autonomous. And the reason I chose those very two specific words is as I was preparing for this event and talking to my buddy Leo and looking at his slides and really listening to what Leo was saying, those two words really kind of just jumped out at me. And I wanted to take those two words and kind of just build upon them and really go a little bit further with those. So before we get started, I do want to say I appreciate you all joining today. I know as has been said, I know it's a little late. It's 4:30 p.m. where I'm at on the East Coast of the US, but I think someone mentioned maybe there's some people across the pond. Anyways, appreciate you taking the time to join us. And I know it's late. We'll try to keep it a little lighter and a little less slide heavy in this session. So maybe that'll help wake you up a little bit. I am Todd Sharp. I am a developer advocate at Oracle. And I've been working for 17 years, basically in the Java and JVM world as a full stack developer until 2018 when I joined Oracle Cloud as a developer advocate for cloud and cloud database. Now, as Leo gave that 5-year kind of overview of where we've been in Oracle Cloud, really, in my personal experience, I've kind of noticed that really since 2018 is really when we kind of jumped to that next level, and year after year, 2018, 19, 20, and 21, things really have seemed to just really grow for us here at Oracle Cloud. I'm not saying it's because I joined in 2018, but I'm also not saying it's not because I joined in 2018. So you can read into that whatever you'd like. But in this session, you're going to learn, hopefully, how Oracle Cloud embraces and enables automation. And I'm going to use a very specific example of our support for infrastructure as code. And of course, it's not the only example, but it's the example that I'll use to illustrate that point today. And as well as how we increase developer productivity with autonomous database. So the first thing I want to look at is the automated portion of the automated and autonomous. And to do that, we're going to look at the Oracle Resource Manager. Now, what is Oracle Resource Manager? Here's a kind of marketing type slide. And me being a developer and a developer advocate, I'm not huge on marketing type slides, but I'll throw this one in there. There's a couple more in there as well. But basically, Resource Manager is a managed service that automates deployment and operations for all OCI resources, right? So Resource Manager is based on Terraform. Everyone, I'm sure, has likely heard of Terraform. It's widely used, open source. It's industry standard. A lot of clouds, I think, are using Terraform under the covers. So it's really no shock that Oracle Cloud chose Terraform. I do want to mention, as Leo had in one of his slides, that, and as he stated, you're going to see a recurring theme with OCI. And that recurring theme is a real recent and kind of very deliberate and intentional focus on open source technologies, open standards, things like this, right? And to me as a developer, that's something that's very important to me, right? Because I, just like many other developers, despise things like proprietary APIs, things that lock me into a certain cloud vendor, right? Other cloud vendors may have different services, different systems that they use, but as a developer, I want my solutions to be as portable as possible, right? Not only because I may move my workload to another cloud at some time, but we're in a time of multi-cloud, we're in a time of hybrid cloud, things like this, where workloads kind of shift from one cloud to another. We may move this bit over to here, as Leo mentioned with Zoom. Their control plane is maybe in a data center, or some of their hardware may still be in a data center. So this hybrid cloud, it makes life so much more easier to have these services that are built on open technologies, right? Now, developers can script and deploy their infrastructure anywhere. So Terraform is what we've built OCI Resource Manager on. The automated part obviously comes in where when we're talking about CI/CD systems, you can integrate your resource manager, your Terraform scripts into your CI/CD system, GitLab, GitHub, some of the other more popular solutions out there. And you can iterate these versions, track your changes, all those things, so on and so forth. Another kind of marketing type slide. I'm not going to cover every single word of this because I really want to get into showing you a demo. I will, however, mention the final point on this slide here is that there is a really nice feature where developers can use resource discovery to scan a compartment in the OCI cloud and create a set of Terraform state files from that existing compartment, existing infrastructure, right? So essentially we're talking about reverse engineering a Terraform stack from an existing compartment, which I think is a really, really cool feature. Of course, the other thing that we should mention that is also of utmost importance is security. And Resource Manager, obviously, it goes without saying that it integrates with our IAM services, so you can define granular permissions, things like this. Very important and built into the Resource Manager. But now I do want to show you a demo. So hopefully you're all familiar with Terraform, and I don't want to assume that you are, but if you're not, this right here is a pretty standard Terraform script that a developer would be working with. And it's just a set of different scripts. And what this package of scripts will do when I deploy it is it will create an autonomous database instance. It will create a full virtual cloud network in the Oracle Cloud. All of the necessary service gateways, security lists, route tables, all of that will be created via this script. So again, this is nothing new. This is nothing groundbreaking at all. And if, as a developer, if I were to want to deploy this, I could very easily come in here and using standard Terraform, I could run TF plan. So this is nothing new, nothing special. But of course, when I do go to run this script, it's going to require some variable inputs. It's going to ask us for some things that we need to provide it so it knows what to build in the cloud, right? So the first thing it asks us here is our database name. So we'll give it a name, ATP1, and then it's going to ask for a display name. Okay, so this is just a simple display name that for our autonomous database instance. So I'll click enter there. Availability domain. Well, see, this is where things get a little tricky and a little bit confusing, right? So I know I'm going to deploy it to Phoenix, and I know Phoenix has 3 ADs, but I don't know the exact name of the availability domain. So let me jump over to this other terminal window here, and using the OCI CLI, I'll just run a quick command and get a list of all of the different availability domains in Phoenix. Okay, there's the list. Okay, Phoenix, ODTI, Phoenix 83. All right, that'll work. I'll use that one. So I'll enter that one. Image ID. Well, okay. That's another one. So let me use the CLI again over here. Write a pretty complex kind of filter with JQ, get a list of all the available compute image lists in this compartment. Okay, or autonomous Linux 7.9. Yeah, let's go with that one. This one looks like the most recent one, so I'll go with that one. Of course, there's all kinds of options here, but that one should work. I want autonomous Linux for sure, so I'll add that over here. And VM shape. So again, this is another tricky thing. So again, I'm going to use my CLI so you can see kind of where I'm going here, right? I mean, this using Terraform to automate cloud infrastructure is helpful. It's great. But when we're talking about repeatability, when we're talking about being error-free, things like this, it becomes a little bit of a chore to look up all of these values. Of course, I could hard code these into there, but that's not very good for redistribution. What if I'm building kind of a stack that I need to share with my team in EMEA, and they have kind of different needs? So the point here is that Oracle Resource Manager makes this a whole lot easier for the developers. And it does that by introducing something called a schema document in the Terraform stack. So what I have here is an example of the schema document. And you can see here that if I define my availability domain, and I give it a very specific type, OCI, identity, availability domain name, I am basically defining the schema for this particular script. And if we zip that up, and now I've created a zip out of this, and if I come back over to my Oracle Cloud Console, and let me zoom in a little bit here. All right, and I create a stack from that zip. Let's see here, we have our zip file, and we can drag that, select that zip file from our directory. And let's see here, what other variables? Click next. So now we get this nice UI that presents us with a really friendly user experience here. I can get dropdowns for region. All of my compartments in my tenancy are presented. My availability domains are given to you in this nice dropdown menu. I can have conditional resources. Whether I want to create a VM or not could be a choice within my UI screen here. If I want to create a VM and then I create, I can add an SSH key here, and so on and so forth. So I can build out my stack by making these choices through this very nice interface, and it kind of builds on top of Terraform, right? It just enhances it, making it a little more user-friendly, a little more developer-friendly, and a little better for distribution, right? We also have the ability to, if I were to go back to the stack information page over here, I can store this entire stack up in a source control system like GitHub. And for example, I have some examples of this myself. I have a GitHub Actions workflow that automatically, once I make a commit to that repository, it bundles up all of my Terraform scripts into a zip, and it publishes them as an asset. And so every single time I do a new push to that repository, my stack is automatically able to pull that latest stack information and reflect the latest information from that repo. So it's a really nice way, like I said, to keep things automated, to make life a little easier for developers. You've all probably heard of Autonomous Database. Leo talked about it a little bit, but I want to focus on two things. One, what is Autonomous Database quickly? And two, why we are calling it a converged database. So the marketing speak that goes along with Autonomous is basically the database uses machine learning. It automates database tuning, security, backups, updates, routine tasks, all of that boring kind of, excuse my candidness here, but those boring tasks that as a developer, I don't like to keep up with. I don't like to do manually. I don't like to write scripts for. I don't want to worry about the operating system updates or security patches or any of that thing. I just want a database that gives me somewhere to store my data reliably, securely, and performant. And Autonomous Database gives me that. So that's the autonomous portion of Autonomous Database. Let's talk a little bit about the Converged Database. And some of our product managers, you might be kind of hearing push this. I know Juan talked about this recently, Converged Database, and we're kind of putting this focus on the Converged Database portion of Autonomous Database. So you have these kind of two contrasting architecture strategies in the, really when it comes to creating applications and microservices as a developer. The first strategy is kind of the traditional single purpose, really focus on the best of breed database for the workload, right? You may have some monitoring data or log data that goes into a NoSQL store. You have some relational data that goes in your traditional relational database. You have text search maybe, and you have an Elasticsearch, so on and so forth. You have Neo4j and a graph database. So you really kind of put each bit of data into a very specialized, very specific engine for that workload. The contrasting kind of architecture strategy is this idea of a converged database that supports multiple data types and workloads, right? Now, I know you're all probably thinking as kind of like I did at first, really, that there's that old saying, like, you can be a jack of all trades, but a master of none, right? And that would kind of be the first thought you might have when you think of putting all these different types of workloads into one database. But I really kind of tend to disagree with that old cliche when it comes to converged database, because I really think the engineering that has been put into all of these different types of workloads really kind of reflects a very strong commitment to making it a database that can properly handle all of these different types of workloads and really work the way it needs to work to handle them properly. So when you're talking about accessing your data, and I'm going to skim through this because I really want to kind of get to the demo, because that's really the impressive part to me. So you get basically, there's different ways to access it, right? So your traditional DBAs are going to kind of go through that SQL, maybe through a REST interface with Oracle REST data services. But then you have this kind of different breed of of developers who are more comfortable with, like, maybe a MongoDB, where they're using these JSON APIs, these libraries to access their data. They're more comfortable with that kind of data access. We support both of these, right? We have Soda, which is a set of libraries that are built for accessing your data in that API kind of way. And we have them for Node.js, Java, Python, all kinds of different options there. But you can also use your traditional SQL that you may be comfortable with to access your data as well. Now, I want to jump into a quick demo here in the last 5 minutes to kind of give you an idea of what I'm talking about here. So, and I'm going to use a database table that is from a recent project that I worked on to do some, basically track some IoT sensor data and capture it and put it into the cloud. And the sensor data is actually sitting right next to me here. I have some seedlings that I planted, and I'm tracking temperature and humidity and soil moisture and things like that. And I'm basically getting them up to the cloud for analysis and automation and things like that. Now, each sensor has different data, right? A temperature may be represented as a decimal. My outlet state is a Boolean, whether it's on or it's off. Light sensor will come in as an integer. So you're talking about kind of unstructured, semi-structured type data here. Now, I could have created different tables or different columns in a table to store all of that data individually, but you lose a little bit of flexibility when you do that, right? What happens if I add another sensor tomorrow, or I change the way some of that data is produced? Well, then I have to update the table. I maybe have to update the data that already exists in the table. I think to me, it made a lot more sense to kind of just keep that data in the semi-structured format that it was in. So I decided to store that data as JSON in a relational table in my autonomous database. And if I run a quick query here, you'll be able to see what that looks like. So I have a green thumb readings table that has my reading as a JSON object, and every 10 seconds, this gets inserted into my table here. So it looks like a JSON string. It looks just like a regular string. And traditionally, maybe 5 years ago, we would have really frowned upon this sort of thing, right? Because you don't have, basically you're kind of denormalized in your setup here. You don't have a really normalized setup that can be easily joined. It can be easily indexed, things like that. So typically it was frowned upon to do this kind of thing. But now that the Oracle database and some of the other engines, of course, support this kind of thing, we can do really cool things with it. So let's imagine, for example, I have another table in this database called outlet states. And this is just a traditional kind of lookup table that has an ID and a state of off or on. Well, what I can now do is with that JSON workload, I can combine that data with my JSON data and actually join the data from a JSON table to a relational type table, and everything would just work the way you would expect it to. So if I join here on OSID equals reading.outlet state, and to get at my data within that JSON string, I can just use a familiar dot notation like this to get at my data. So if I run that, so you can see here, I can easily join that traditional JSON workload to my traditional type relational type table. I can also, again, get at those actual properties within the JSON string using a dot notation just like that. So I can pull things in and out of the table or that JSON string, JSON column, just like its traditional relational type data. So to me, the big win here is obviously that, again, like I said, you're looking at that jack of all trades, kind of master of none. Well, with Oracle Converged Database, and it's not limited to just JSON, we're talking about graph data, we're talking about XML, we're talking about all of these different types of data, all being combined into one database that can handle them and handle them really well, that's managed for the developer, for the DevOps engineer. Updates, patches, all of that awesome stuff is handled for the developer. So I hope that that kind of gives you a peek or a little bit of a understanding as to why I wanted to focus on autonomous and automation in my session. If you do have any questions, I'll be happy to answer them.
If you use the autonomous database, can you interact with it with existing drivers that are expecting more of a traditional database interface? Like if I'm used to using Mongo, can I use the same Mongo drivers to talk to this thing?
You cannot do that. You cannot do that today. Now, that said, there are, well, I should say specifically for Mongo, you cannot do that. Now, traditional ORM tools like Hibernate work absolutely fine. So, of course, anything that could talk to Oracle database before can still talk to Oracle Autonomous Database, and all of the traditional tools that a developer, in my case, a Java developer, using Hibernate, things like that, those libraries will have absolutely no problem switching from whatever you were using before to Autonomous Database. Soda is kind of the solution, and I didn't show you any specifics about Soda, but Soda is very similar to a Mongo type API, where you have that kind of traditional insert document, remove document kind of syntax. So it's very similar, but it's not fully compatible. I really do, as a developer, I wish that we had something like that, because I think that is a good story to tell, and I think it's a very easy sell at that point. Now, like Leo said, if you look at our streaming service in the cloud, it's 100% compatible, compliant with the Kafka API. So you could drop in the Kafka API. So that's kind of an example of where that's something that works the same way that would be nice if we could do as well with Autonomous Database. But Mongo APIs, no. Traditional libraries and frameworks, things like Hibernate, things like Juke, and some of these other type frameworks and tools, absolutely.
Are there plans to offer that type of compatibility?
I don't know. I don't know. I would love to see it, but I don't know if there are plans.
Back on the previous resource manager stuff with Terraform, that YAML definition that you showed, is that something that you have a bunch of existing templates someone can grab off of GitHub to use? so they don't have to build it themselves? Or is that something you can have Oracle Cloud build for you and then just add it to your Terraform project?
So if you go into Resource Manager and you create a stack, you can create a stack from almost like reference architectures or sample type schemas. And that schema doc will be included. Our documentation is really good. It illustrates, or it tells you all of the different options for the the types of different types of lookups you can do. You can also do validation with that. In other words, if, for example, if you wanted to create a form input for password, you could have validation applied to that. So you have a very specific, stringent password, validation. So there is a full schema documentation available in our docs that is really good and kind of how I learned about it. But at the same time, you can download those reference and take a look at those and use those as examples to learn a little bit more about that schema. But again, it's fully optional, right? I mean, you don't have to do that. You can run your Terraform scripts the traditional way. And if you're integrating them into a pipeline and invoking them via a pipeline, it's actually probably going to be a little more performant to run them the traditional way in your pipeline. If you want the flexibility that, if you're going to be distributing, if it's an open source project, for example, and you want to give people a one-click button on their GitHub repo to deploy the stack in their own cloud, it's a great solution for that.